In this video, I'm going to talk about intermediate value theorem. Let's start off with an example. Let's say you are in San Francisco and you go from, let's say, point A, which is right here, to point B. To go from point A to point B, you follow a straight line, okay? Now, to get to point B, from point A, you have to go through every single point in between A and B. So let's say you walk, okay, and you keep going this way. Every single point you have to cover between points A and B. Now let's go ahead and put a coordinate system on this. So let's say this is my y-axis and this is my x-axis. All right. This is y and x. Now, in going from point A to B, you vertically covered this distance, right, from here to here. So, technically, your vertical distance coverage is this. Now, imagine that the line from point A to B, it is a function. If it is a function, this is what happens. For every point on the line, okay, which corresponds to the y-axis value of this, right, there is a corresponding x value. So if this is x and this is going to be your y. And it is true for any point on the line A to B. It's a continuous path that you have taken, okay? So that means there is no gap or no holes in between. So between A and B, the straight line you're taking, it's a continuous path, okay? In our case, we'll call it a continuous function or a smooth function. That means it will take on any value between this and this. So which means that for any value, vertically, whatever the distance may be, okay, whatever the value may be. So let's say I'm considering this point, there will be a corresponding value x there. This is literally the gist of intermediate value theorem. Let me go ahead and define it more mathematically a little bit. So let's consider that you have a function f, okay? You have a function f that is continuous in some closed interval, let's call it a comma b, all right? And then we will have two values. Let's call the first one f of a and the second one f of b, the boundary points. And let's make the assumption that they are not equal. If they are not equal, then we could find some number in between them, right? Let me call that number k, okay? So I'm going to call that number k. Remember, this k is in the range, not in the domain. It's in between f of a and f of b. So k is an element of f of a comma f of b. By the way, I don't know which one is which one is bigger in this case. I'm just making the assumption that f of a is less than f of b, or it could be the other way around too. If f of b is less than f of a, then we just need to switch it. That's about it. Now, if k is a number in between f of a and f of b, then intermediate value theorem kind of tells us that there must be some number c. There must be some number c in the interval ab, okay, ab, such that f of that number c is equal to k. Again, f is a continuous function on the closed interval ab, and f of a and f of b are not equal, and we pick a number k from that interval, f of a comma f of b, right here. It could be f of b comma f of a if f of b is smaller than f of a. Now, for this k in this interval, there exists a c in the domain such that f of c is equal to k. That's what the intermediate value theorem is telling you. However, for you to remember this thing, always think of this example. Very simple example. You're going from point A to B on a straight line, right? So to go from point A to point B, you have to go through every single point in between A and B. So it's an example of a continuous function. And if you pick any point between A and B, there has to be a corresponding X that's going to be going in as an input to the function and giving you the corresponding value y. Or another way of saying the same thing, for every y value on this line, there should be a corresponding x value. Now I gave you a very simple example right here with a straight line. In reality, it will not be a straight line. It could be any shape or any type of function so long it is continuous. I gave this straight line example so that you can remember. So you could have a function like this, right? Going like this. Your f of a is going to be here, f of a, and your f of b could be right here, right? It goes from a to b. That's an example. Or you could have something like this. That's a continuous function, right? So your a could be here and your b could be, let's extend it here. So your f of a is right here and f of b could be right here. You can see how you could have different possibilities or literally infinitely many possibilities for this situation. But the main thing you want to keep in mind is that you are dealing with a continuous function, in a closed interval, and f of a and b are not equal. And if you take any point in between f of a and b, for that point, there should be a corresponding x value that will give you that value. That means that value in the range. So for each point in the range, in the interval between f of a and f of b, there should be a corresponding x value. So it gives you the guarantee of the existence of such x, okay? It gives you the guarantee of the existence of such a value c, such that f of c is equal to k. And it has some great applications, intermediate value theorem, and we are going to talk about it in another video. I hope that this discussion was helpful. Thank you very much.